PerfectLearn TV.
Hi, I am Teacher Sai and I am here to give you a lesson about geometry. Okay, our certain topic for today is about the areas and volumes of solids. So are you ready? Let's start our lesson. So our first topic for today is about the prisms. So what are the prisms? Prisms is a solid figure that has two parallel congruent sides that are called bases, which are connected by the lateral faces or the parallelograms. So the parts of the prisms are shown in the figure. So as you can see, the two congruent faces are the bases. So the bases can be found, it's either in the upper part and the lower part. The other faces are called the lateral faces. So these are the faces on the sides. Lateral faces intersects in the lateral edges. So this is the intersection of all the lateral faces and all the faces which are parallel and congruent. So if the lateral edges are perpendicular to the planes of the bases, the prism is called right or the right prism. And if the lateral edges are not perpendicular, of course, to the base, the prism is called oblique. Sometimes you can determine whether it's right or oblique when the oblique one is in slanted position. Okay? And a regular prism is one whose bases are regular polygons. So when the bases are polygons, so you know what are the regular polygons are. So we have square, rectangle, heptagon, hexagon. Okay, so those are called regular prisms. A segment is an altitude of a prism if and only if it is perpendicular to the planes of both bases of the prisms. So the length of the altitude of a prism is called the height of the prism. In the right prism, the height is the same as the length of any lateral edge. So the lateral and surface area of a prism. So when we talk about the lateral area of a prism, it is the sum of the areas of the lateral faces. Or, can be in symbol, this is the perimeter of the base multiplied by the height of the prism, or the lateral area is equal to PH. And when we talk about the surface area is the total area of a prism. It is the sum of the lateral area plus the area of the two bases. Or, in symbol, we have the perimeter of the base multiplied by the height of the prism or the lateral area plus 2 multiplied by the area of the base. Or, surface area or the total area is equal to PH plus 2B. Always remember when we talk about the base, the area of the base, take note what kind of polygon is what type of polygon the prism possessed. If it is a square, okay, so we use the area of a square. If it is a rectangle, we use the area of a rectangle. So it depends on the polygon it possessed. So next, we have the volume of a prism. So the volume is the amount of space occupied by the figure. So determining the volume of a figure means determining the number of cubic units that can be placed inside the figure. So if in area, we talk about the square units, in volume, we talk about the cubic units. So the volume is equal to the base area multiplied by the height of the prism, or the volume is equal to BH. So these are the simple formula for the area and volume of a prism. So now, let's proceed with the example. So let us apply the formulas that we have talked about so that you can apply it on your own. So here is an example that demonstrates how to find the surface area and volume of a prism and really highlights both of these formulas above. Okay, so let's start with the surface of a prism. So we have the given. So the given in the figure, we have 6 feet, okay, 2 feet, and 5 feet. So what are the names of these givens? So when we talk about the 5 feet, this is the height. The 6 feet is the length. And the 2 feet is the width. So for the base, what I have told you before, remember, depends on what kind of polygon the prism possess. So this time, this is a rectangle, so therefore our base is equal to length multiplied by width. Okay, so therefore we have 6 multiplied by 2 feet, and that is 12 feet. So substituting the values, so we have, for the total area, we have 16 multiplied by 5 plus 2 multiplied by the base of 12. So computing for the values, the total is 104 feet square. Okay, so that is the area of the prism given. So for the volume, so the volume is the base multiplied by the height. So our base is 6 multiplied by 2. So we have 12 feet multiplied by the height is 5 feet is equal to 60 feet cubed. That's all for the prism, and now we're down to our next solid. And we have the pyramids. Pyramid is very common for us. So we know that pyramid is a polyhedron having for its base polygon and for the faces triangles with common vertex. Okay, so have you know the pyramid of Egypt? No, those are the example of pyramids. Okay, so the parts of pyramids we have here. So the vertex is at the tip of the figure. The lateral face, we have the base at the bottom, the base edge, and we have the lateral edge. And of course, the altitude, we have the altitude or the height. So the prism, the same principle with the prism, but we have what we call the slant height. Okay, so the slant height is from the vertex up to the base edge. Okay, so it can be computed or can be measured between the vertex and the base edge. Okay, and also regular pyramid can be it can be characterized using the regular polygons. Okay, as the base of the figure. Okay, so the lateral and surface area of a pyramid. So for the lateral area of a regular pyramid equals 1/2 product of the slant height, or L, and the perimeter, P, of the base. So in symbol, we have 1/2 L P. And of course, the surface area or the total area of a regular pyramid equals the lateral area plus the area of the base. Okay, so same principle with the prism. The area of the base depends on what kind of polygon the base possessed. Okay, so we have area is equal to lateral area plus the area of the base, L plus B. So the volume, let's move with the volume of a pyramid. The volume of a pyramid is 1/3 the product of its height and the area of its base. So volume in symbol, we have 1/3 base times height. Okay, so to apply the area and volume of a pyramid, I have prepared here an example for you to answer. So find the area and volume of a given regular pyramid. So the figure above is you can see the figure. So we have what do we call the square pyramid, because the base, okay, it depends, okay, on the base. So the base is in square, so therefore this is the polygon is square, so this is a square pyramid. So for the given, okay, we have the slant height or the L as 5 meter, as you can see. The base edge is 6 meter and the altitude is 4 meter. So to find the area, let us use the formula for the total area. We have 1/2 LP plus the area of the base, or the area of the square. Okay, so 1/2, substituting the values given. So we have 1/2 meter multiplied by 24 meter is 60 meters square, plus the area of the base, which is the base edge square. So we have 6 meters square is 36 meters square. So we have to add, okay, so adding to the lateral area, we have 60 meters square plus 36 meters square is 96 meter square. So therefore the area is 96 square meter. So for the volume, so the formula for the volume is 1/3 base times height. So same given. So substituting the values, we have 1/3 6 meters square multiplied by 4 meter is, we have 1/3 times 36 meters square times 4 meter is equal to 48 cubic centimeter. So therefore the volume is 48 cubic centimeter. Okay, so that's how easy, okay, just how easy to compute the area and volume of a pyramid. Okay, so that is when the givens are the given information or the given values are already given in the, or already dictated or stated in the figure. Okay, so let's move with the another solid, okay, another area and the volume of a solid. What do we call cylinders? Cylinders, what are cylinder? A cylinder is a tube and is composed of two parallel congruent circles and a rectangle which base is circumference of the circle. So these are the parts of a cylinder. So we have the base, the lateral face, we have the axis, so the axis, the radius, and the lower base. So the bases are the upper and the lower bases. Okay, so just like the prism, so we have the upper and the lower base. But in here, in cylinders, the bases are only circles, and the lateral surface is a So the lateral and surface area of a cylinder can be computed as the lateral area of a right circular cylinder equals to the product of the circumference of the base and the height of the cylinder. So when we write it in symbol, we have the lateral area as the circumference multiplied by height, or, okay, so when we derive this formula, we have circumference can be computed as 2 pi r. 2 pi r multiplied by h. So the lateral area will be 2 pi r h. So for the total area, we have the total area of a right circular cylinder equals the sum of the lateral area of the two bases. Okay, so in symbol, we have the lateral area or the 2 pi rh plus 2 multiplied by pi r square. Okay, so because the base can be computed as pi r square. So to derive or to make it simple, to simplify the formula, we have the total area of 2 pi r, the quantity h plus r. For the volume of a cylinder, okay, it is equals the product of the base and the height of the cylinder. So in symbol, we have base times height. So the base can be computed as pi r square multiplied by h. So we have pi r square h. So for example, we have, okay, find the area, the total area and the volume of the cylinder given in the figure. So we have the figure here. So given, we have the radius of 6 centimeter, the height of 12 centimeter. So for the area, total area, we have a formula of 2 pi r quantity h plus r. Okay, so we're going to substitute the given values. So we have 2 pi multiplied by 6 centimeter, the quantity 12 centimeter plus 6 centimeter. So when we computed that, we have a total area of 216 pi square centimeter. Okay, so we use the radian value. Okay, so for the volume is pi r square multiplied by height. So again, substituting the value. So we have pi multiplied by 6 centimeter square multiplied by 12 centimeters. So we have a total of 432 pi cubic centimeter. So that is the volume of a cylinder. Okay, of a given cylinder. That's all for the cylinders, the total area and the volume of a cylinder. So let's move with the another solid. So what do we call this? Is the cones. So cones. In geometry, the word cone refers to a pyramid-like structure with a circle-shaped base. So the base is a circle. So it's like a pyramid, but in pyramid this polygons. But now in cone, this is a circle base. Okay, circle-shaped base. It is a three-dimensional figure and has a circular base, has tapers to a point vertex, apex of on the top, and the shortest distance between the vertex and the base is called the height. And the distance from the vertex to a point on the base is the slant height. Okay, so these are the parts. So we have the vertex at the tip of the figure, the lateral surface. Okay, so we have the base. Okay, the base is the circle. The axis is from the vertex to the middle of the base. Okay, so these are the axes, and the slant height is from the base to the base edge. Okay, so the edge of the base. So the lateral and surface area. So to solve for the lateral area, we have the lateral area of a right circular cone having a slant height L and the base circumference. So the circumference, as I told you before, is can be computed as 2 pi r, where r is the radius of the base, is 1/2 the product of the circumference and the slant height. So in symbol, we have 1/2 CL. So to elaborate more, we have 1/2 the circumference, 2 pi r, multiplied by L. And let us simplify the formula. So the lateral area will be pi r L. So for the total area, okay, total area of a right circular cone is the sum of the lateral area and the area of the base. So we have the lateral area plus the base. So we have pi r L plus the area of a base is pi r square. So to simplify, we have pi r quantity L plus r. So let us go with the volume of a cone. So for the volume to compute, we have a cone is 1/3 the product of the base, the area of the base, and the height. Okay, so we have 1/3 base times height. And to elaborate more, okay, using the base, the formula of the base as pi r square, we have 1/3 pi r square times h. So that is the area and volume of a cone. So let us apply, okay, the formula of the area and the volume of a cone in the given figure here. So we have the given radius of 5 cm and a slant height of 10 cm. So to find the area, we have the pi r quantity L plus r. Substituting the value given, we have pi multiplied by 5 cm multiplied by the quantity 10 cm plus 5 cm. So a total of 75 pi square centimeter. So as I told you before, we use the radian. Okay? So that's why there is a pi there. Okay? So we didn't use the value of pi as 3.14. So for the volume, we have 1/3 pi r square multiplied by height. So again, substituting the values, we have 1/3 pi multiplied by 5 cm square multiplied by 10 cm. So we have 250 over 3 pi cubic centimeter. Okay, so it's okay to use fraction. Okay, so there is nothing wrong using fractions. But if you want to use the numerical or use the decimal, okay, you can use that also, but there's nothing wrong using the fraction form. Okay, so these are the area and volume of a cone. So let's move with our last solid. We have the spheres. Okay. So spheres is a set of points in a space equidistant from a given point called the center. So when a plane intersects a sphere in a more than one point, the intersection is a circle. And if the plane passes through the center of the sphere, the intersection is a great circle. So as you can see in the figure, sphere is like, okay, so I can relate sphere is like a ball. Okay. So these are the parts, okay, of a sphere. So we have a center, okay, the radius, okay, the diameter from the left edge to the right edge, so that is the diameter. So the surface area, so in sphere we do not have lateral area, so we're going to find the total area. Okay? So the total area of a sphere is equal to the sum of the areas of the 4 quadrants of the sphere. So the surface area of each quadrant is equal to the area of a great circle. So the area is 4 pi r square, or 4 multiplied by base. Okay, so pi r square, as I said before, that is a formula for base. And the value 4 is the quadrants. Okay, so we have 4 quadrants in a circle or in a sphere. Okay, so for the volume of a sphere, so the formula for the volume of a sphere can be found by using the formula for the volume of a pyramid. So just like the volume of a pyramid, think of dividing the surface of a sphere into polygons and then joining the vertices of each polygon to the center of the sphere, forming pyramids of height, the radius of the sphere. So as you can see in the figure that I gave to, that I provided for you to imagine. Okay, so to illustrate more in your mind how to find how to compute for the volume and how the volume computed be. Okay, so the volume is 4/3 pi r cube. Okay, so this is 4/3 pi r cube. So for example, so a globe of Earth is in the shape of a sphere with radius 14 centimeters rather. So find first the volume and second the surface area and round the answer to the nearest 100. Okay, so let's find the area. So the area can be computed as 4 pi r square. So our given is a radius of 14 centimeters. So we have 4 pi 14 centimeter square, and we have a value of 784 pi square centimeter. So that is the area of globe. Okay, so globe in the reality globe. Okay, so next we have the volume. So the volume can be computed as 4 pi r cube. So we have 4/3 pi multiplied by 14 centimeter cube, and we have a total value of 10,976/3 pi cubic centimeter. Okay, so cubic centimeter. So those are the areas and volumes of solids. So to recapitulate or to review those solids, we have tackled about the prisms. The second one is the pyramid. The third one is the cylinder. The fourth one is the cone and the sphere. So those solids, I gave you the formulas on how to find the area and volume and how to apply it in the problem. Okay, so if you have questions, you can search. Okay, you can internet and or in books. So we have so many references about the areas and volumes of the solids. But today, this are our topic for today. So thank you for listening and thank you for your cooperation. And that's all. Thank you.
Thank you for watching. Please subscribe to PerfectLearn TV for more videos and updates.